So in this video, we will continue to talk about push and pop instruction. Then we will show you how to use the push and pop operation to reverse the content of a string. So the first thing, let's finish what we talked about earlier in the previous video. So the push instruction, they will have one operand followed by the instruction. So they can be either immediate value, or they can be register or memory operand for either 2 byte or 4 byte. If that's 2 byte, the ESP will decrement by 2. If that's 4 byte, ESP will decrement by 4. But if they are immediate value, ESP just by default, they will decrement by 4. So the same thing, your pop instruction, actually they will also have an operand. So you have one operand followed by that, and this operand will save the value pop from the stack. So that's why there has to be either register or memory operand. So the same thing, they can either be 2 byte or 4 byte. So the pop instruction actually first copy the content of the stack element pointed by the ESP. So then according to your operand size, they will read either 2 byte or 4 byte to the destination operand, then they will increment by that. If the operand is 2 byte, so that will be increment by 2. If the operand is 4 byte, the ESP will increment by 4. So that's why one thing is earlier, we say the push and the pop is important to keep the order for the stack. Not only your ESP cannot be accessed or updated by any user-defined instruction, and also you need to make sure you know which will be the next value you will push in the pop. So then your order won't be wrong. So for example, earlier you did push 2 bytes to the stack. So then when you do the pop, you make sure they are 2 bytes. Otherwise, if you don't make sure, the easier way is you just always push 4 bytes. Then you always pop for the 4 bytes. So that's the push and pop instruction. So the next one, we will see how we will use that and combine with what we have a loop we learned from the last chapter. So this one is we will have a string, but that's reverse the content. So actually this one is the same thing you did from your last assignment or lab exercise, right? We can, just one thing is we have the source string. Then we either reverse the source string and copy to the target string. So then you see you can using the address to copy over. But one now, since we have the stack, so then we can try to push all the content of the string to the stack. Then when we pop out, they will automatically become the reverse order. So that's why we will just push each character into the stack. Start at the beginning of the string. So then we pop the stack in the reverse order. Insert each character back to the string. So how to reserve the content of the byte array without any additional array declared. So that's we using the stack to save the value. Before, remember in your lab exercise 6, you have source string and target string. You copy the content from the source string, then copy over to the target string reversely. Then you need to have 2 arrays. But now since we have the stack now, we don't need another additional array declared. Instead, we just have 1 byte array called a name. So then the name only just Abraham Lincoln. So then you don't need to declare another byte array. So then we can just make the name become reversely for the Abraham Lincoln. So then we will see how to do that. So that's the example we show you. That's our reverse string file. So make sure I have that on Canvas. You need to make sure you will download that source file and run from your Visual Studio. So you can see here we have the name is the byte array. So that's Abraham Lincoln. including the no character for the end of the string. So now we need to do using the loop, right? So how to know how many number in this array? So before we can using the length of the array. So how about this time we just using the $sign operator. So remember the $sign operator will point to the current location, right? So the current location minus the beginning for the name. So then you will -1. So here -1 just mean because we only want to reverse Abraham Lincoln. We don't want to reverse including the 0. So on the other hand, how many letter we need to reverse? We only start from A to N. So then you see the no character, we just still leave there. That's why if you're using the length of to get a name, you need to be careful the length of including the 0. So that's the size for the whole array. So you can either use the length of you -1 or $sign minus the beginning of the memory address for the data label. So this one in the parentheses is the length of the byte array. But one thing is how many times we need to reverse. Actually, we do -1 because we don't want to reverse the no character. So that's why here after we have the name size, right, we're just using that to move to ECX as the counter. And earlier we say that's using the index addressing. So we use the ESI start from 0. So ESI start from 0. So then a name ESI, you see this one is we call the index addressing. So now in order to push the value, okay, so you can either push this one. However, you couldn't do this one is, you see, a name is what kind of data size? Right, it's byte. Supposedly I want to push the A to the stack, right? But one thing is, remember we told you earlier, your push only can be either 2 byte or 4 byte. So that's why here, if you only have 1 byte value, you need to try to extend the value, then you push. Otherwise, the push only allows 2 byte or 4 byte. So in this case, in our example, we move the A to EAX. So since we move the value is 1 byte to the 4 byte, we use the move ZX. So we have 0 extension. So then here we will push the EAX into the stack 1 by 1. So don't forget you increment the ESI. So then you will have your ESI move to the A to B. So then continue with loop back to this location. So the first beginning, what we do is in this first loop, we only copy over the character 1 by 1 into the stack. And since we cannot push only 1 byte, so we move the 1 letter into the EAX. Or you can do AX, so that's up to you. So why must each character be pushed in EAX before the push? Right, because only word or D word can be used for the push to the stack. So in this example, we do AX, or we do EAX. But of course, if you want to do the AX will be fine. But after our loop, L1, we only finish what? Yeah, right. We only finish to copy over all the letters start from A to N. So now, right, we need to have another loop, right? So now they are already in the order 1 by 1 in the stack. So then we will pop to the start from beginning for the array. So then we will overwrite the name. So that's why here we need to have another loop. So here, actually, this one will be the whole code. So then after we finish the push, let's do the pop. So again, your ECX need to have the counter for the name size first. So then you see your ESI actually reset to the 0. So now afterward, we will start pop from the memory stack. So then earlier you push as the EAX. So now you need to pop as EAX. So when you copy your EAX, right, remember, we only have one letter. Okay, so that's why after you have EAX, but only AL can read that character. So that character we will copy over using the index addressing as well. So that's why you see N will be the first one pop. So they overwrite this location. So then continue with the loop. So afterward you will see the whole string like this. So don't forget to see here, right? We have the string, we watch that in the memory window. So afterward you can see they did being reversed and overwrite the original one. Okay, so let's make sure we will run from our Visual Studio. Okay, so let's run our RevStr.asm file. So we download from our demo file, Module7. So in this file, actually, we're still using the COMSC260 Chapter 3 project. So then you can see here, is earlier we show you, you will have your name byte array defined. Okay, so then we have two for loop. Okay, so the first for loop is for the push. So you can try here, we're using EAX. You can try if you change to AX, how that work like that. But if you change to AX, you need to make sure the other array will do that the same thing as well. Okay, so then you will see here, the second loop will be pop the value from the stack. So when you run your program, to make sure you see here, that set couple breakpoint. Because for now, actually, we only can run from chapter 3 project. So that's why you didn't have any output from the screen yet. So that's what we'll do here. But here, just see, without debugging, we see the program run fine. Or make sure program run fine before you can do the debug mode. So now we just debug again. So when you start using the debugging, you see here, we will have the watch window show. But the memory window didn't show, so then you need to open the memory window. Okay, so we open our memory window. So then you see they didn't show anything, right? Because you didn't give them the location for the array you want to read. Okay, so after you enter a name, your name you enter, so then you will see they display. You see here, you just see the value. So that's in 1 byte. Then they will be in ASCII value. So in order to see the text, they will be like here. So beginning, actually, before the loop, actually, we just have the original array, right? So that's why you see here we run. Okay, you see, because they only access the stack on the stack, so that's why you don't see anything change from your output. So in the loop 1, actually, we just access each character into our stack. So then after this loop is done, now we need to do a few times. So you see, again, we start doing the loop 2. Okay, so that's why you see here. You see N change now. So then L be overwrite 1 by 1. We pop from the stack. Then we copy over to overwrite our NaN byte array. So then you see here, they do 1 by 1. Okay, so after they done, you see, oh, yeah, then they finish. I didn't show you, but you can see actually the sample output will be the same. So the apparently can actually will be the reverse order. So please make sure you will download the RevStr.asm file. So run from your IDE. So that's the most important thing. So earlier you see the memory window. So then actually they will be the same afterward they done. That's the output. So in this one, the RevStr.asm file, we still run from COMSC260 Chapter 3. So later, right, so the most important thing for this class now, we will run from the RevStr.asm library. So that's why you will see we will have another updated RevStr.asm file. So from there, actually they will include RevStr.asm library. So then we will see they will call write string procedure and display the console from the output. But before that, I will show you the next video how to set up your environment to link your RevStr.asm library. So then we run another sample file. So then you will see you can see the array result in your console.